Hi ladies and gentlemen, this is Mr. Green and we're going to continue with our trip down imaginary lane and we're going to start talking about complex numbers today. What's the difference? Well, I'll get to that in just a second. Don't forget, get all your work turned in. We're getting close to the end of the semester, so we want to make certain we're getting all the work turned in and not late on anything, okay? So, where are we? Complex numbers. Complex numbers are really nothing more than imaginary numbers with additional parts to them. We'll talk about it. We're going to show you how to add and subtract them. We're going to show you how to graph them on a complex plane. And we're going to find a new mathematical approach called the modulus of a complex number. Okay? It's kind of interesting. The children are getting too complex for me. Haha, it's math humor. Very poor math humor. So a complex number is nothing more than a real number and an imaginary number put together. So if you look at the real number and the imaginary number added together, they look something like this one right here. A plus BI, where A is the real part and B is the imaginary part. Okay? That means if I put 0 in for A, I'm talking about nothing more than an imaginary number. If there was a 0 in B's location, I'd be talking about, well, 0 times I is still going to be 0. I'd be talking about a real number. So guess what? The complex numbers is a superset, or a set that includes all the real numbers plus the imaginary numbers as a completely separate set of numbers. So here we've been talking about things that fit into the real number range. And we're talking about some numbers that are actually outside of that range. So they're a superset. They're bigger than the real numbers. So let's look at them. There are basically, uh, if I'm comparing real numbers, if I'm comparing complex numbers, I have to make sure that both the real portion and the complex portion are congruent to each other, are the same values. If they are, then you can say two complex numbers are equal to each other. If they aren't equal. So to make certain they're equal, you have to make certain of that. To add complex numbers, you add the real portion of it, minus 6. You add the imaginary portion of it, plus 3i. Now, some people like to go ahead and simplify to do something to this and say, well, that's 3 times negative 2 plus I. But you know what? Either one of those would be the same thing in my opinion. So we'll just leave it at that. So let's look at subtracting. If I've got negative 5 minus 8, that's a negative 13. If I've got negative 2 minus 11, that's a negative 13i. And so this one, I guess if you simplified it, you get negative 13 times 1 plus I. 1 plus I. And that would be the way you add and subtract complex numbers. Now, can we graph them? Sure. What we do is we let this be the real number line and this be the complex or imaginary. So what I'm going to do, when I'm plotting 3, 2, I'm going to go over on the real number line 3 and up 2 for the imaginary number. If I'm looking at 5, negative 3, I'm going to go over 5 and down 3. 1, 2, 3. And that will be my point right there. If I'm looking at negative 2 plus 2i, I'm going to go back 2 and up 2 plus 2i. So that would be C right there. If I'm looking for point D, it's over 6. 1, 2, 3, 4, 5, 6. It's right here on the real number line, D. If I'm looking for 4i, negative 4i, it's going to be on the complex number line right down here at negative 4i. That would be E. Do you see how these are graphed? This becomes your X, this becomes your Y value basically, if you want to think of it as an XY coordinate, but it's not. X's are on the real number line, The imaginary numbers are on the imaginary number line, and they're graphed separately. They make an ordered pair. Okay? Let's move forward. If I were looking at these, can I find these points? Sure. Let's look at point R to begin with. Point R is going to be located at -3, -4. That means my real number, or my complex number that I'm looking for here is -3 minus 4i. Let's look at M. It's located at the point 5, -2. That means my complex number is going to be 5 minus 2i. Well, let's look at Q. Q is located at 0, 6. That means my complex number is going to be 0 plus 6i, or just 6i. Okay? Now, modulus. Modulus is the way of finding the distance. That's all it is. This is the distance formula. It's the Pythagorean theorem applied to the complex numbers. Okay? If I'm looking for 4 plus 3i, I would go over 4 and up 3, right? It'd be located right there. Well, I've got a Pythagorean theorem triple that I could actually work on right there, don't I? That's over 4, up 3, 4 squared 16, 3 squared is 9, that square root of 9 is 5. Right? But these were real and imaginary directions. And this 5 is just a distance. It's a distance between them. It's the distance from the origin, this point right here, to the point that we're talking about. That's all the modulus is. And so what do you get? It's always a non-negative real number. It will always be just a real number, and it will never be negative. Non-negative real number. That means it could have square roots, it could have a few other things, but it won't be a negative number. Okay? How do we write this? We write the modulus with lines around it like that. Okay? But how do we find it? It's by taking the squares of the numbers and taking the square root. Okay? So here's another one. 2 and minus 5i. So I'm going to go over 2, down 5. 2, 3, 4, 5. There. That's what I would be looking at. So we'd be looking at a triangle that goes like this. It's got a 5 distance there. It's got a 2 distance there. 2 squared is 4. 5 squared is 25. 25 minus 4 is 29. So what is my distance going to be? Square root of 29. Positive number, real number. It's a positive real number. That is my modulus. Okay? They're telling you over here, write it in simplified radical form and then estimate it to the nearest tenth. Well, 29 is not a number that can be factored, so I'm not going to factor it any, but I can estimate it. I can type it in on the calculator and find its square root of 29. And I get 5.38 or 5.4. So this is approximately equal to 5.4. Going forward. That's the way you do these. If you have questions, feel free. Come into Toga. I want to get your questions answered. I want you to understand this information. We're getting too close to the end of the semester for you not to understand it. So, come to Toga. I appreciate you guys continuing to let me know who is on your or that you're in Algebra 2 so that I can find your information and get answers to you quickly. Talk to you later.